All right, let's talk about C++. If you've ever glanced at code and felt like you were trying to read an alien language, well, you're not wrong. But it's a language you can totally learn. Today, we are going to crack the code on C++, one of the most powerful and important programming languages on the planet. So, let's just dive right in.
Okay, take a look at this. This right here, this is a complete working C++ program. I know, it might look a little cryptic right now, kind of like a puzzle, but trust me, by the end of this, every single part of this, every weird symbol, every word is going to make total sense. We're going to take it apart piece by piece together.
So first things first, let's look at the big picture. The basic blueprint, the scaffolding that holds pretty much every C++ program together. Think of these as the fundamental rules of the road before we get into any of the fancy stuff.
Let's start right at the top with that first line. Hash include IOStream. That little hash symbol there, that's a signal. It's an instruction for something called the preprocessor. You're basically telling the computer, hey, before you do anything else, go and grab the IOStream library. A library is just a bunch of pre-written code that lets us do useful stuff, like, in this case, printing text to the screen. It is exactly like gathering all your tools and ingredients before you start building or cooking.
Next up, you see int main. This one is a big deal. It is absolutely non-negotiable. Every single C++ program in existence must have a main function. It's the official starting line. When you hit run, the computer immediately looks for main function and starts following the instructions inside. It really is the front door of your program. You always have to start there.
And what's inside that front door? Well, you've got these curly braces. Anything and everything between them is the body of the function. That's the list of instructions the computer is going to follow. And that very last line, return 0, that's just a way of telling the operating system, hey, all good. I did my job and everything went smoothly. That 0 is basically a universal thumbs up for a successful run.
Okay, so we've seen the overall structure, the skeleton of the program. Now let's zoom way in. Let's talk about the smallest individual pieces of the language. If a program is a sentence, these are the actual words, the punctuation, the grammar. In the programming world, we call these tokens.
And here's the cool part. Every C++ program is just built from 5 basic types of these tokens. You've got punctuators, think semicolons, braces. You've got operators, which are for doing stuff like addition. Literals are just fixed values like a number or some text. Identifiers are the names that you create for things. And finally, keywords. These are special, reserved words that the language already understands.
Now, it's really important to get the difference between those last 3. Think of it like this. Keywords, like if or while, are reserved. They're part of the language's built-in vocabulary, and you can't use them for anything else. Identifiers, on the other hand, are the names you invent for your own stuff, like variables. And literals? That's the raw data itself, the actual number 12.5, or the text hello. One is a command, one is a name you create, and one is the actual value.
So now that we know the words, we can start forming sentences that actually do something. And this is where programming starts to get really smart. We're going to talk about control statements, which let a program make decisions and choose which path to follow. It's kind of like turning your code into a choose-your-own-adventure book.
The most basic decision maker of all is the if statement. It's incredibly simple, but oh so powerful. You just give it a condition to check, a test, and if that condition turns out to be true, the code inside the if block gets to run. If it's false, the program just skips right over it and moves on. As simple as that.
But what if you need a plan B? What if you want something specific to happen when the condition is false? That's where else comes into play. A plain if statement gives you one path, do this or do nothing. But an if-else gives you 2 distinct paths. If the condition is true, do this thing. Else, do this other thing. It's a fork in the road for your code.
And what if you have more than 2 options? Well, you've got a couple of great choices. You can use an else-if ladder, which is basically just chaining a bunch of checks together. You ask, is it this? No. Well, else if it's this? No. Okay, else if it's that. It's great for a series of different, unrelated questions. The switch statement, though, is your best friend when you're checking one single variable against a whole list of specific values. It's often much cleaner and easier to read for that kind of job.
Making decisions is one thing, but the real superpower of programming, the thing that makes it so efficient, is repetition. This is where we teach our code to do the same task over and over and over again, without us having to lift a finger. We're about to put things on autopilot, with loops.
So the official term is iteration statements, but everyone just calls them loops. The idea is simple. You tell the computer, here's a block of code, and I want you to run it repeatedly, as long as this specific condition is true. Once the condition becomes false, it stops. These are the absolute workhorses of programming. They do all the heavy lifting.
Now, the classic for loop is a thing of beauty because it bundles the three key parts of any loop into one single clean line. First, you have the initialization, which is just setting up your starting point. Second, the test expression, that's the condition that it checks before every single run. And third, the update statement, which is how you move towards the finish line, usually just adding 1 to your counter. All three parts, where to start, when to stop, and how to get there, right there in one place.
Now here's a really important detail about loops. When do they check their condition? Most loops, like for and while, are what we call entry-controlled. They check the condition before they run the code inside. This means if the condition is false from the get-go, the loop might not run even once. But then you have the exit-controlled do-while loop. It runs the code first and then checks the condition, and that guarantees that the code inside will always run at least one time.
Okay, last big concept for today. Sometimes you're in the middle of a loop and you need to break the rules. You need to get out early or maybe just skip ahead to the next round. How do you do that? Well, for that we have jump statements.
First up is the break statement. The best way to think about break is like pulling the emergency brake on a train. It is a full stop. When your code hits a break statement inside a loop, it immediately kills the entire loop, no questions asked. So in this example, we're supposed to count to 10. But we have a rule. If our counter hits 5, break. So the code prints 1, 2, 3, 4. Then it gets to 5, the condition is true, break fires, and the loop is just over.
Now, let's compare that to continue, because the difference is so important. Continue doesn't pull the emergency brake. It's more like hitting the skip track button on your music player. It just says, you know what, I'm done with this particular round, let's just skip the rest of the code and jump right to the start of the next one. So look at the example. It's almost identical, but when the counter hits 5, the continue just skips the part that prints the number and moves right on to 6. The result? You get every number printed except for 5.
And that's it. We've done it. We've gone from a totally cryptic block of code to understanding its blueprint, its basic words, how it makes decisions, and how it handles repetition. We've cracked the code. So I'll leave you with one final thought. Now that you know these fundamental rules, what's a simple, repetitive task in your own daily life that you could actually imagine automating with code? Something to think about. Thanks so much for tuning in.